Hey, welcome to the Astronomy in Depth. My name is Blake Nancarrow, and I'm joined by,
Chris Vaughan. Blake and I are both members of the Royal Astronomical Society of Canada, Toronto Centre.
we wanted to talk to you about the Jupiter-Saturn conjunction that's coming up. This is pretty exciting, and there's been a lot of information in the media about this. The big night is on December 21st, which coincidentally is the beginning of the winter solstice. The big picture here is that Jupiter and Saturn have been getting closer and closer together over the summer. A lot of us were watching this in the spring and the summer, and gradually Jupiter's been getting closer and closer to Saturn. On the 21st, they're going to be as close as they can be to each other in the sky. In space, obviously, they're very far apart, millions of kilometers, but from our perspective on Earth, they appear to get very close together. And this is going to be really cool. You can view this in lots of different ways. So we're going to talk about how you can look at this with just your eye. You don't need any special equipment, but if you've got binoculars, that'll be pretty cool to look at both these planets, the gas giants in binoculars. And if you have a telescope and you can use a low power eyepiece, you can start viewing these two planets together soon, maybe in the next day or two. And then on the 21st again, they'll be as close as they can be. Of course, we're in the northern hemisphere and it's winter up here, so who knows what the weather will be like. But if we're lucky, we'll be able to see this and maybe photograph it and enjoy this. We'd like to do a little bit of myth busting along the way because there's some confusion, things that aren't very clear in some websites that you may visit. So hopefully we can demystify things a little bit for you as well.
It's
Go ahead,
seeing it
Chris.
in the eyepiece. That's what's going to make it a great conjunction for folks like me.
Indeed. Now, something that we want to emphasize right away is that there's a 20-year cycle going on. The video, I'm going to run this video while I'm talking. So I'm going to start this and watch the top left-hand corner for the date for a moment. Let me just get this started. I'll pause it just after it starts. Here we go. So we're late 1999 or early 2000. And you can see that Jupiter and Saturn are kind of lined up here. So that's when the last conjunction of Jupiter and Saturn was. But I'll let the video run now. You see the Earth is spinning around very quickly. It's on the fast track in the inner solar system. Jupiter is moving faster than Saturn, of course. But you can see that it's pulling away from Saturn now. We're in the early 2000s and so on. So we'll keep an eye on that. But the conjunctions of Jupiter and Saturn happen every 20 years. It's because Jupiter takes about 11 years to go around the sun. Saturn takes around 29. Now it's a three-body problem. The Earth is moving too, and the orbits aren't perfectly circular, and there's orbital inclination, some other factors. But a bit less than 20 years, this synodic cycle occurs where Jupiter and Saturn nicely line up. They get close together in the sky. Some conjunctions are better than others. Some are easier to see. The sun might be in the way. You can see Jupiter in the video is catching up here. It's 2017. We're coming up to 2018. I'm going to pause it here in a moment just so we can get a good look at it. I'll just pause it here. Oh, I'm sorry. I made it jump all the way to the beginning. There, sorry.
So that's a top-down view, isn't it, Blake? That's looking down from the so-called north pole of the solar system down onto the sun and the orbits.
Now we're in our imaginary spaceship floating over top of the solar system, and you can see the planets are moving in a counterclockwise way around the planets, around the sun, excuse me. So a key point, a key takeaway here is that the conjunctions of Jupiter and Saturn are not rare. They happen every 20 years, so you got to wait a little bit. And again, some are better than others. What I'm going to do now is ask Chris to demonstrate some of the conjunctions from our perspective on Earth at different times. So let's switch over to Chris. He's going to use planetarium software to show the view.
Yeah, so I'm using the Stellarium software, the free open source at stellarium.org that you can download on a MacBook or a PC, or you can even get it for your smartphone, your tablet. So I'm showing a simulated view of the sky based in Toronto this evening, December 17th at 5 p.m. You may have heard on Twitter or the news or social media that the crescent moon will be up there in the sky with Saturn and Jupiter tonight. So it's a terrific photo op. But Blake's going to feed me a number of the dates for these other conjunctions, and I can simulate any date and time using the Stellarium.
Chris, while you're on the 17th there, do you want to zoom in a little bit so we can see the moon near the planet?
Sure.
You're right. This is going to be tonight. It's going to be a great photo opportunity.
Yeah, so essentially the sky won't be getting dark enough to really pick up fainter Saturn until about 5:30. So let me just advance the time a little bit later. So 5 p.m. you might grab Jupiter. And once you do that, you can look closely for Saturn to its upper left. But by the time you get to about 5:30 p.m. local time, and this is good all around the Northern Hemisphere. So 5:30 p.m. in your local time zone, look to the southwest for this phenomenon. It's not limited just to Canada or the Toronto area. So by that time, you can see the two planets are quite prominent in the darkening sky, and then the beautiful crescent moon sitting, hugging the sky near them.
Okay, great. Thanks for that. Do you want to go back to early June 2000, 20 years ago, in the morning, 5 a.m.?
All right, so let's go to 2020, June. Here we go. There's Jupiter. I can put that in the middle. And let's see. Running the time back. What time would you like?
5 a.m.
Let's go to 5 a.m. There we go. So we're looking into the southern sky. And
do you have maybe June 7th, 2000?
Oh, it jumped up to 2020 on me here. I guess that didn't take. Here we go. 2000.
There we go.
June 7th. There we go. What I can do here, Blake, is I can actually add a simulated binoculars field of view. Why don't I do that? Just so people get a sense of the scale of the sky here.
Now, Chris, do you remember observing this conjunction back in the summer of 2000 in the morning? I don't remember looking at this or seeing it.
No, I don't. I actually tend not to be too much of a before dawn astronomer, so it might even not have gotten me out of bed.
I hear you, brother. Yeah.
But I noticed the Pleiades are tucked up here in the corner. It would have been low, above the horizon, but
yeah.
It would have been a cool little setup.
Just a hint of it. We got a better one there for the Pleiades coming up soon. So can you check the distance from the sun there? Because it looks like the sky is pretty bright.
Yeah, so the Jupiter would only have been about 22 degrees west of the sun at that point. So obviously, if I advance the time forward, you can see the sun will come up. By the time the sun gets close to the horizon, we lose the planets in the glow. But
and how far apart are Jupiter and Saturn from each other there? Can you measure that, please?
That would be approximately, I'm going to say, about 1.5 degrees. So that would be, a couple of finger widths apart.
Yeah. Chris just mentioned a way that we can measure things in the sky. Take your hand and stretch it out in front of you, splay your fingers, and your little finger, your pinky finger, is 1 degree. And if you put 3 fingers together, that's 5 degrees. So there's little tricks there that you can use to measure things. So Chris mentioned that the two planets were just over 1 degree apart. And for a lot of us, 1 degree is kind of a magic number for a conjunction, because 1 degree is about the size of the field of view the circular field of view that you see in a telescope at low power. Small telescope, low power eyepiece, you can see about a degree, maybe 2 degrees of the sky. Binoculars can show 5 degrees, maybe 6 degrees of the sky, a much wider swath. But 1 degree, we get excited usually when that happens because it means, oh, maybe we have a telescopic target. So we looked at now 20 years ago, that was the May 2020. Chris, do you want to go ahead now, 20 years from now? I suggest November 2nd, 2040. And it's also going to be in the morning again, 5 a.m. So November 2nd, 2040.
November 2nd, 2040. And
5 a.m.
yeah, for me, for Toronto, we need to be closer to 6 a.m. and later than in order for them to be together.
Oh yeah, maybe 7. Yeah.
Yeah.
Get them a little bit higher in the sky.
Normally when we're looking at objects near the horizon, they can be very blurry, especially in binoculars or things like that, or telescopes, because we're looking through so much of Earth's atmosphere. So astronomers like to get them a little higher above the horizon before we start using telescopes on them so that they're clearer to see. So they're about 10 degrees above the horizon at this point, about 7 a.m. on November 2nd.
And I think if you are specifically on November 2nd in 2040, Mercury's pretty close to them.
Yeah, there's Mercury just below them.
Yeah, so that's
and the crescent moon above them.
Yeah,
so that's a terrific photo op.
Yeah, Mercury is often really hard to see, but if you've got a good beacon nearby, like bright Jupiter or the moon, that can help you see the elusive inner planet. So to me, that's a pretty interesting conjunction. That's going to happen 20 years from now. And according to my notes, the planets are about 1.25 degrees apart. So it's similar to what we saw 20 years ago, just over 1 degree, not super close or super tight like what's happening in a few days. Let's go ahead another 20 years now. Do you want to go to April 2060, April 6th, and it's nighttime, it's 9 p.m. April 6th, 2060, 9 p.m.
There we go.
This one's awesome. You spotted the Pleiades in the morning dawn sky back in 2000, but I think this is incredible, this conjunction.
Can almost fit the whole gang together in binoculars. This would be, I think, a 6 degree field for binoculars. You can get wider field binoculars than that. But yeah, look at the group we have, the collection we have in the sky.
That's awesome.
Saturn and Jupiter, the Pleiades, open cluster, or the Seven Sisters, as some people call them, Subaru. And there's Venus tucked into the edge, masquerading as an 8th sister. That's terrific. That's going
to be so impressive. It'll be great to look at with eyeballs. That's lovely in binoculars, and with a wide field camera view, that'll be pretty spectacular as well. And the skies.
Well, I was going to say another thing, Blake, we haven't talked about, maybe we'll get into, is that Venus and Jupiter are actually bright enough to see in the daytime if you know exactly where to look. So it's usually helpful if the moon's nearby to guide you to them. But man, if you could pick up either Venus or Jupiter on that date, you could scan over to see the other planet at the same time in the daytime sky.
I'm going to add that to my calendar. And I hope by April 2060, I'll still be alive.
Me too.
I'll be old and creaky then, but we'll see. Now, some people are describing this conjunction as a once in a lifetime event, but you've seen now, we've shown you that every 20 years we get into different sort of conjunctions. Let's do one more. Chris, go forwards another 20 years to March 16, 2080. And this is back in the morning again.
March 16, 2080. Here's 6 a.m. on March 16th, 2080. And you can see they're closer together.
So the media is presenting that there aren't conjunctions until 60 years from now. And there wasn't a good one except 800 years ago. So clearly we're showing every 20 years or so, you get interesting conjunctions. What's significant about the one in 2080 is that the planets are very close together, like they will be in a couple of days. They'll be 1/10 of a degree apart.
Now, let me add I'm going to change my circle to a telescope view now. So I'll put it to that 1-degree telescope eyepiece view you mentioned. And so now everybody can see the blue circle would be the field you'd see in your telescope. And there are Jupiter and Saturn tucked nicely comfortably inside the field of view of your eyepiece.
They're so close together that I think it'll be amazing to look at in a telescope, because you won't be able to tell which planet the moons belong to. The moons are going to intermingle there. That's going to be really neat. Except all have to be 117 years old or something like that. But
okay.
I think I'll be missing that one. But anybody that's young, looking at the conjunction happening in a couple of days, this is not a once in a lifetime event. In 2080, you'll be able to enjoy a really good one as well, where planets are really, really sort of close together like this. So they happen every 20 years. That's our key point. Some are better than others. Some are in the morning. If you're not a morning person, so be it. But that's sort of pretty neat. Now, there's a bigger cycle going on here. You can see that for some of these, Jupiter and Saturn are within a degree, very close together, in fact, in some cases. And then other conjunctions, they're not so close. They're more than a degree apart. There's a larger cycle happening. This is a 400-year cycle where you get close conjunctions, where Jupiter gets very close to Saturn. These are rare. Obviously, every 400 years we get these good events, so this is definitely a once-in-a-lifetime type of thing when these happen. So I'm going to ask Chris again to show us some of the key dates. Let's go back 800 years. That's March 4th, 1226. 13th century, and in the morning, 5 a.m. Again, March 4, 1226, in medieval times.
There we go.
5 a.m. So there we go. That's a really nice looking conjunction there. And you know what? Those planets would have been, Jupiter and Saturn would have been 2 arc minutes apart from one another. Very, very close together, and they're in a dark sky. They're well away from the sun. Again, if we were looking at this through our telescope, there were no telescopes back then.
Correct. And you also had a naked eye star sitting in the same field of view, which is terrific.
Yeah. So what people observing this would have seen is 2 points of light drawing close together, forming 1 point of light, and then splitting into 2 points of light sometime later.
Let me just take off some of the annotations here. There's sort of the way the sky would look.
I think Venus is nearby too. So again, there would have been 2 bright beacons off in the southeast before dawn to really catch people's attention there. So pretty spectacular event, astronomical.
And of course, the planets change their location night after night, morning after morning. So at the same time, we've got a few days before that, perhaps a week before that date, we had this fantastic triangular trio of Venus, Saturn, and Jupiter all in one group in the sky together.
Fantastic.
So that would have been really set tongues a wagging for sure.
Yeah, if we could go back in our time machine and take our telescope with us, that would be pretty spectacular. The other key date that people are talking about is July 16, or the summer of the year 1623. So let's go to July the year 1623 into the evening time.
Let's find Jupiter, and we'll go into the
Now,
evening
on
sky.
December 21st, now, this month, Jupiter and Saturn are going to draw as close as 1/10 of a degree or 6 arc minutes. In 1623, they were a bit closer. They were 5 arc minutes.
That's
so
right.
A little closer together there. But yeah, what's going on?
Look how low they were.
Low, and the sky's really bright and stuff like that. What's interesting about this date, 1623, is it was 13 years after Galileo Galilei was using his new telescope to observe Jupiter and the moons of Jupiter and Saturn. In 1610, he made his first observations and records of the planet Jupiter and the planet Saturn. But we've been looking to see if we can find records from Galileo or other astronomers with their new telescopes viewing these planets, and we're not finding any records. And it's probably because the sky was so bright that, sure, maybe Jupiter was visible, but not Saturn at the same time. And the sky was so bright that it even if they used their telescopes, which were very rudimentary and didn't offer great views, that probably Saturn was invisible to them. So that's too bad.
I can set it up to a more. There you go. By the time the sun had gone down, they would have been only visible perhaps less than a few finger widths above the horizon. So very difficult to see them.
Yeah. Even though they didn't have any light pollution per se to speak of, and less air pollution and so on, it just looks like the odds were not in their favor for viewing this event. So that's important. What that means is, Chris, you want to go back to now?
Yeah, here's tonight.
December 21st. That's what's significant about what's happening now and over the next couple of weeks, that we're likely going to be the first humans to view with magnification the conjunction of Jupiter and Saturn this close together. And many people are going to be photographing this, so this might represent the first photographs of Jupiter and Saturn so close together. So this is historic. We are witnessing history here. This is a big deal that these planets are so close together. Particularly because it looks like Galileo didn't see anything or didn't make any records of it, nor did any of the other early astronomers. And that's why we want to really emphasize to you now, you need to get outside. Every clear night for the next couple of weeks, go out and look at it. If you have your binoculars, put your binoculars on these objects. If you have a telescope, get ready with your low power eyepiece to start looking at these planets, and they'll start to appear in the same telescopic view at the same time. And on the 21st, when they're really, really close together, we'll be able to use high power eyepieces in our telescope to see details on the planets.
So Blake, even though every night they're getting inexorably closer and closer together, they'll reverse the process after next week. After Monday, they'll begin to draw apart again, kind of in the reverse mirror order. But of course, at the same time, they're both being carried closer to the sun's glare every night. So the preceding week is far better option for looking at them than the following week, even though we'll have comparable separations between the two planets.
Those are really good points, and I hope that underlines as well that this is not a one-night event. We might get clouded out on the 21st. We might not have good conditions. Be that as it may, we need to look as often, as frequently as we can, and try our photographic opportunities as much as possible. But yeah, this is not a one-night only event. enjoy the view anytime you can, but through to the end of December, it's going to get more and more difficult. Just for clarity here, I wanted to show some numbers, a little bit of math here in terms of distances and the sizes of objects. We've been talking about degrees. We've been talking about minutes or arc minutes here. So a degree, you know, is divided into 60 minutes. That can be further subdivided here. And we've talked about the 1 degree field. That's kind of the magic number for a low power telescopic field. And the circle that's showing on this slide around the moon, that's a 1 degree field. And you can see the moon is half a degree in size, or 30 minutes in size. And that's regardless of whether it's a super moon or a micro moon. The media likes to use those terms of late. When the moon's at perigee, it's a tiny bit bigger. When it's at apogee, it's a tiny bit smaller in the sky. That's very hard to tell just with your eye. So it is more or less half a degree or 30 minutes in size. But on the 21st, Jupiter and Saturn are going to be 6 minutes apart. So that's 1/5 of the diameter of the moon. The little tiny Jupiter and Saturn images below the moon image here are at the 1/5 diameter separation. So that gives you a sense of how close the planets will be in relation to the size of the moon. And that 1 degree circle, that's sort of a telescopic field, that'll give you a sense of how close and why it's significant, how close these planets will be.
And of course, that's a simulated view there. We're not going to see the moon, Jupiter, and Saturn lined up in an eyepiece like that.
Yeah, that's kind of like
don't create a meme. Don't create a meme, please.
Yeah, that's like the perfect alignment out of 2001: Space Odyssey by Stanley Kubrick. We're not going to get that. So
no, okay.
Yeah, just a simulation here. A little technical matter: when we look at things in the sky, and we're talking about degrees and minutes, that's on a curved surface. It's like everything is on a sphere. So we talk about arcs, curved lines. So technically, we're talking about arc degrees and arc minutes and so on. But Chris and I have been using just the short form, just saying degree and minute, just to quickly refer to these terms. But technically, we're talking about spherical geometry here. Now, this table, there's a lot of information here, and Chris has touched upon a lot of these things already. A week ago, we found the planets at an azimuth, if you have your compass out, at a position of 215 degrees. That's to the southwest, basically. But you can see over time, the planets are moving to the west. The altitude, Chris mentioned that a couple of times, but the altitude a week ago was 17 degrees, but now it's around 15. And it's getting lower. On the end of the month, the planets are just 9 degrees above the horizon. Now, all the while, they get close together and then start moving far apart. A week ago, they were about 1.5 degrees apart. Now it's the 17th, right? So they're about half a degree apart, 30 minutes or maybe 35 minutes. But we're interested in the key moment here is on the 21st when they get 6 minutes apart. That's going to be pretty good. And then they'll start separating from each other. Now, because they're so low in the sky, we're looking through a lot of air. So the air mass column is referring to that. If you go outside on a nice clear night or even in the daytime, you look straight up, of course, towards the zenith, you're looking through one atmosphere, one layer of our atmosphere, 1.0 air masses. But when you look at things sort of at an angle, down low, close to the horizon, you start looking through more air. And already we're looking through about 3 or 4 air masses. And if the air is kind of dirty, if there's turbulence, if there's some low-lying cloud, I don't think we have any smoke or ash from forest fires right now to worry about. But we have lots of atmosphere that we're looking through. And that might make for a bit of distortion in our view. Astronomers refer to the quality of, one of the qualities of the air that they're looking through in their telescope as the scene, or the scene conditions. And that refers to how steady the air is. When you look at these planets through your binoculars or through your telescope, you might see that they're sort of shifting and shimmering a little bit, and that's due to the poor seeing conditions, which is exacerbated when we look through more air.
So Blake, I've heard from a few people who've basically bought telescopes for the purpose of seeing this conjunction, and they've commented that, why can't I see Jupiter and Saturn clearly? And they haven't appreciated that that's because you're only looking at them when they're so low in the sky.
Yeah.
If you want to see nice crisp views of Jupiter and Saturn, we're going to have to wait till they pass conjunction and return next year when they climb higher in the sky.
It's almost like you're scuba diving and you've got your mask on, and the water and the waves and stuff like that is going on, that we're looking through, almost like we're looking through water when we view the planets this low. So a lot of astronomers use those terms. They describe the view as swimming, or it's badly shimmering. So again, astronomers call that the seeing here. So the air mass levels are getting worse over time, but I'm not going to wait around for good seeing conditions. We all need to look as soon as we can at these, and we take what we can get with respect to the seeing. But if it's shifting and shimmering a little bit, that's to be expected. Okay, what do you need to do this? Well, you need an eye. You're going to need warm clothes. Tonight it's really cold, so I'm going to put lots of layers on when I head out. We obviously, because it's so low, we need a really good sight line to the southwest. So no trees can be in the way, no buildings. If you live in a high rise and there's not a building in the way, and you can look to the southwest, you'll have a great view. We're going to encourage you to go outside, not just for 1 minute or 2 minutes, but dress comfortably, put lots of layers on, more layers than you think, and grab a lawn chair, go into the garage or the shed, get the lawn chair out, maybe get a lounge or a recliner, lie down and have a good look at the sky. If you're lucky, you might even see a meteor. Aren't there some meteor showers going on right now, Chris?
Could have some lingering Geminids, some leftover Geminids, or even some sporadic meteors. We've got Starlink satellites you're likely to see pass over as the sky gets darker.
The big thing that we need, though, is clear skies. So obviously the weather is a big sort of factor here. So again, any clear night you get, you kind of want to be ready to go.
So Blake, a lot of people have difficulty appreciating just how low they're going to be in the sky. I've been advising them to, if you head out and your skies are clear to the southwest and you're not seeing Jupiter, have a walk around. It might be hidden behind the corner of your neighbor's house, or behind a tree or something like that. Got to sort of look around and get that sight line.
Yeah, and surprisingly, another sort of curious factor is it can be hard in a perfectly clear sky at seeing the planet at first just with your eyes. But if a plane goes by, tonight the moon's nearby, so the moon helps. It helps you focus in the right area. So your eye can trick you by not focusing the right way. So Chris and I have tried to emphasize you don't need equipment for this. We'll get lovely views of this conjunction with just our eyes. We've talked about a couple of tricks to be able to spot the planet here. I would suggest actually even going out before sunset, have a look around, and if you know where to look and you can focus well, you might be able to pick up Jupiter even before the sun has officially gone out. I actually, a lot of times I'll grab my binoculars and I'll sweep around until I see Jupiter. Then I take the binoculars away. I know where to look. For about an hour to 2 hours after sunset, though, as the sky darkens, you should see Jupiter pop out very clearly. Saturn is dimmer, though. It's much dimmer. So they're not equal in their brightness. This kind of screen snapshot I'm showing you kind of alludes to that. It's because Jupiter is so much further away in the solar system. It's also a little bit smaller, of course, but Saturn will emerge as the sky gets darker. Remember,
I think they're about 10 or 12 times difference in brightness between the two planets.
Good point. Look while you can. Look to the southwest. The snapshot that I did there is from a couple of days ago in Stellarium, and you can see the tree lines there and stuff like that. And this is happening now. So it's a key point that we want to emphasize. If it's clear for you wherever you are, go out and look tonight, and be ready to go around sunset time. So check your local sunset times, but it should be around 4:30 to 5 o'clock that the sun goes down.
I was going to say, Blake, that I know we're talking to Canadians here, but the farther south you live on Earth, closer to the equator you get, the more vertical the plane of the solar system is against the horizon. So people who live at low southerly latitudes, they get a bit of a bonus on this because the sun dives down more earlier than planets will, and they can see them in a darker sky.
Yeah, that'll help a lot. If you've got binoculars, you can start using them now. The planets are close enough together that they'll fit into a field of view. These two little bright points here are Jupiter and Saturn first at the top left, and Jupiter at the bottom right. I forgot to mention that when you see Jupiter, look up and left and go at about a 45-degree angle. And they're about a degree apart. Remember the trick I mentioned before? Put your hand out and use your pinky finger to measure 1 degree. So look up and left about 1 degree, and you should see Saturn from Jupiter. Or another way to put it is use the clock face. Look at around the 10 o'clock position, about 1 degree away, and you should see Saturn. A challenge can be getting a steady view with your binoculars. You may have binoculars that have a tripod mount, but maybe you don't have the adapter. But if you've got a tripod, you've got the tripod adapter for your binoculars, then put your binoculars on a stable platform. If you don't have that setup, maybe just lean up against your car. There's been times where I've used my binoculars and I put one of the tubes up against the tree or a building to stabilize the view. If you can do that, if you can stabilize your view in the binoculars, that'll give you a very nice view. You'll see some background stars, and look closely around Jupiter. You might see little points of light in a row. Those are the moons of Jupiter, and they'll be more or less aiming towards Saturn. And you might see a little faint point near Saturn. It won't necessarily line up with Jupiter and Saturn or the moons of Saturn, but you might be able to see the big moon around Saturn tighten with your binoculars. So that's pretty good. And again, you can start looking at that now. If you have a telescope and if you use a low power eyepiece, you could start looking at the planets maybe now in your telescope, depends on the power and the focal length and so on. But a couple of days before the 21st, through to a couple of days after, the planet should be close enough that using 25 power or 50 power in your telescope will draw the planets close together in the same field of view for your telescope. On the 21st, which we've talked about, when they're as close as they can be to one another for this conjunction, 6 arc minutes, they will fit nicely in an eyepiece field of your telescope at fairly high power. You can start going to 100, 150, maybe 200 power. And of course, when you start using higher and higher magnification in your telescope, you're going to see surface details on the planet of Jupiter, the cloud bands, and maybe the great red spot. And you might see shadows of the moons on the planet of Jupiter if some of those are occurring during this time period. On Saturn, you'll be able to see the ring system, and you'll be able to see a bunch of the moons around Saturn. So that's going to be pretty great. Again, we've got a small window of opportunity here, and hopefully the weather will cooperate. But again, have your telescope ready to go a couple of days before through to the 23rd of December to enjoy the two planets together in the same day.
Hey, Blake?
Yeah.
I just checked with Stellarium, and the great red spot will be transiting visible on Jupiter tomorrow night,
Very
the
good.
18th. And just passed it on Monday, back again on the 23rd with a shadow transit, which probably won't be visible. But we've got a couple of those nights, the 17th and the 18th and the 23rd, where you can see the great red spot in your
But
view.
by itself, Jupiter is great to look at. By itself, Saturn is great to look at. Now we've got two in the same eyepiece at the same time. It's double your fun. So yeah, it's gonna be great. Now, what if you want to photograph these? Again, you can do this with pretty simple equipment. You don't need a lot of stuff. If you have a digital single lens reflex camera, if you have a point and shoot camera, if you have a smartphone, you might try these devices to get some images of this. To do wide field photography, which is the simplest kind of photography to do, you want the camera or your smartphone to be as steady or stable as you can. If you've got a tripod for your camera, that's great. Use that. If you have one of those grip sort of things, I forget what they're called, little things that can hold your smartphone steady, that would be good, a nice stand or something like that. Or just lean your smartphone up against a solid object of some kind. You should be able to get some nice wide field views of the two planets really close together. If you include some scenery, like the tops of the trees, or a windmill, or something like that, that can make for a very attractive photograph. You may need to shoot a fairly long exposure, like a couple of seconds, maybe upwards of 10 seconds. Your point and shoot camera, it might have a fireworks mode to help you do that, or your smartphone might have a low light mode. So try those modes, but also be aware that if you press the shutter on the camera or the smartphone, you shake it, you vibrate the device. So to get rid of vibration from you activating the shutter, put it in self-timer mode. Or if you have a remote release, use that to trigger the camera. So try those things. And again, you can do this kind of photography right now, because a nice wide field shot, really easy to do, and you'll have the two planets there. Okay, what if we want to zoom in a little bit? Lots of people are using trackers. These have become really popular. That little red sort of thing here, it's a little tiny specialized motorized mount that you can attach your camera to, and it rotates at the same rate as the sky. An old classic way of doing this was for people that had a telescope with an equatorial mount. They could put an adapter on top of the telescope, attach their camera on top of the telescope. That was called piggyback photography. But now doing this, you're tracking the sky, you're following the sky, and that means you can put a long lens on your camera or zoom in optically with your camera. I did this a couple of weeks ago with my 70 to 210 millimeter lens, and I used f4, I used ISO 800, I shot for 4 seconds, and I got a nice exposure. If you can see your histogram graph on your camera, if your camera shows you that, that can help you check the exposure. So not too dark, you don't want everything crunched up against the left side of the histogram or in the blacks. So check your exposures, or do the trick called bracketing. Shoot some 2-second shots, do 5 seconds, do 10 seconds, and see what the best photo is. Again, use your timer or the remote release. Yesterday, the moon was in the scene. Chris mentioned that today the moon is nearby. He showed that right at the beginning. So tonight's going to be fantastic for a wide field or a bit of a zoomed in shot, including the moon. So that'll be really, really nice if you get some photos like that. So give that a try. To get high detail, if you want surface details of Jupiter, the cloud bands, if you want some of the moons of Jupiter, if you want Saturn and the rings in it, you're probably going to have to attach your camera to your telescope. And usually we need some adapters to do that, and T-rings and so on. You can see we have a camera attached to a telescope, and it's on a special mount that can track the sky. Technically, strictly, you don't have to have that if you have just a telescope that you push or move manually. You can still hook your camera up to it, but you'll have to shoot a very fast exposure so that you don't get blurring from sky motion, the sky rotating. So if you have a tracking mount or an equatorial mount, you can do some really long exposures. and hopefully get some nice photos there. And again, use your timer, or if you have an intervalometer, or if you're controlling your camera with software, then you can be hands-free and that avoids any vibration. How much of the sky your camera telescope combination can see will determine when you can start shooting to get both of the planets in the frame. You may have to rotate your camera a bit and put them in the corners, the key corners, to get that. But probably a day or two before the event to a day or two after, you should be able to get the planets on your camera sensor. Another thing that you can try here is afocal photography. This is also pretty easy to do. Assuming you have a telescope and you're tracking the object or you're on the object, you can hold your smartphone or your point and shoot camera up to the eyepiece. The challenge is getting the camera or the smartphone really steady. You can get little brackets. If you're creative, maybe you can rig up some brackets and clamps to hold the camera in the correct position and at the right angle over top of the eyepiece. But that's a great way to get a magnified view of the planets. And once again, the window of opportunity, it'll vary a little bit depending on your telescope magnification capabilities in the eyepiece that you're using, but a couple of days before and after the 21st, you should be able to do all that.
Hey Blake, if you're hand holding your smartphone, one option is to record video, and then you can clip out frames where you've actually successfully captured the view of the planets as you sort of move your camera over the eyepiece.
Yeah, thanks for that. That's a great point. So weather's a big factor here. You know, Environment Canada, if you look at the trend information, shows that days are clear only 20 or 30% of the time. It's usually just a portion of the day. So watch your favorite websites for weather information. Astronomers use cleardarksky.com. We use the clear sky charts, and you look for dark blue chips. So look at the 1600 through 1800 hours, 4 p.m. through 6 p.m., and look for dark blue in the cloud and the transparency. You can see on this occasion, transparency is not great, but we do what we can. There's lots more information. Take a snapshot of that slide or do a screen capture of that slide. Lots of websites are noted here. Chris regularly reports on astronomical events on his skylights at astrogeo.ca/skylights. You can check out my blog where I regularly post information about astronomical events, blog.lumpydarkness.com. I watched the University of Exeter videos on the Jupiter Saturn event, and they had some great information there. And they get into some of the math of the 400-year cycles. Websites for RASP, for the Toronto Centre, astronomy clubs around the world, observatories, the space agencies are all going to be trying to show live views of these planets. So if you're clouded out at home, you can probably see some good views on your computer. Chris, do you want to talk about another conjunction?
Yeah, so I'm not sure I buy into the notion the media is spinning that this is a capital G great conjunction. By the time Jupiter will be close to Saturn next Monday, the total is not greater than the sum of the parts, if you know what I mean. They won't magically become suddenly brighter just because they're tucked close to one another. But when we do get fantastic conjunctions is when we get the two brightest planets meeting up. That's Jupiter and Venus. And we don't have to wait long for that. So in the spring of 2022, April 30th of 2022, in the pre-dawn sky, it'll be worth getting up for this one. Jupiter and Venus will be very close together. Again, I'll just measure it off here. I think it's half a degree or so. Yeah, about a full moon's diameter. So about less than your pinky finger's width apart. They'll make a spectacular sight. Photo op wise, you've also got the planet Mars off to their upper right on that same morning. And we may even get the moon joining them. Let's see if we
That's
get
on the
there's the
27th.
moon on the 27th. So on the 27th before dawn, about 5:30 a.m. in the eastern sky, you're going to get the crescent, the old crescent moon, Jupiter, not as close to Venus, and Mars off to their upper right. So that's really a fantastic photo op and great conjunction in my opinion.
Thanks for sharing that. So hopefully we've been able to share with you some good information about the conjunction of Jupiter and Saturn that's sort of happening right now. And again, we wanted to emphasize that conjunctions of Jupiter and Saturn happen every 20 years. So if we get clouded out for this one, too bad, but we'll try again in a short while. Super close conjunctions of Jupiter and Saturn, those are rare. They happen in about 400-year cycles. The next close one, similar to this month, will happen in 60 years. But again, the next 20 years, we've got some good ones. The current one, over the next couple of nights or the next couple of weeks, is going to be visible for about an hour or two each evening around sunset. So be ready. The specific instance or moment of conjunction is at 6:37 p.m. Greenwich Mean Time. So that's the exact moment when they're as close as they can be to one another. For a week or two before and after the 21st, about a week before and after the 21st, the planets are 1 degree from one another. So that's now. They're fitting in binocular fields now. So go and have a look. And then a couple of days before and after, we should get telescopic views. But don't wait too long because, as Chris mentioned, they're getting closer and closer to the sun and lower in the sky. So it's going to get harder and harder to see this. I hope that we've made it clear to you that you can enjoy the view with just your eyeballs, your Mark 1 eyeballs, or with your corrected vision. So go out whenever you can, good weather, and have a look. Any closing comments, Chris?
Just to take advantage, as you said, don't delay. Every clear evening that you get, check the weather, head outside. It just takes a minute to poke your head out and take a look, and enjoy the sight.
Okay, thanks a lot, Chris, for joining me and sharing information about the conjunction of Jupiter and Saturn, along with other conjunctions that are happening. So keep in touch with us. Visit our RASC Toronto website. We're on Facebook, we're on Twitter, we're on Instagram. Check out our YouTube videos. Lots more information is available. But thanks for your time. And if you're in the Toronto area, go out and look now. It's going to be a great evening.
Yeah, after about 5:30, it should be good. So I usually